So, according to science, we live on a spinning ball called the globe. Well, as that's just fantasy, I'm going to use this beach ball to represent the spinning globe model, as it helps to understand perspectives. So here we have Anthony Riley, and I'm going to put him on the spinning globe. Now, no matter which way Riley looks, left, right, back or front, he's always going to be looking both downwards and at a curve. Now, heliocentric priests will have you believe that from your perspective you cannot see the curvature on the x-axis. That is the horizon line, in case you're wondering. So, they say Riley cannot detect curvature that way. They assert curve can only be detected by looking through the murky layers of air that lie just above the ground on the z-axis. Okay, so if he cannot detect it, then perhaps someone looking at him could. Because if he is on a spinny, bouncy beach ball, then wherever I view him from, at distance, I should see the ground curve away. Take a picture and very easily see the curve. Here is the Rio Antirrio Bridge, almost 2 miles long. It's curved, just like the spinny ball, so I think I'll stick Riley on it. Now I'm going to look at him on my x-axis, and I can see that it curves. This should help in my next experiment. So I noticed Wolfie6020 has been observing a lighthouse with his P900 and claiming to see curve. Well, applying the exact same logic as I've just demonstrated, I'm going to do a quick screen grab and see if we can get some curve on his x-axis, because there looks to be a lot of it. So from his elevation, I determined the horizon to be 12.15 miles away. So using Google Earth, I'm now going to triangulate his position and put in 2 lines, both at 12.15 miles away, so I can work out the ocean horizon length. This comes out at 12.5 miles. So using math and the curvy ball calculator, I plot the centre at 6.25 miles, and see that if I stick Riley on the sea, just as I did on the bridge, I should be able to detect 26 feet of curve. Sorry Mick West, your standard refraction nonsense has been thoroughly debunked and won't play a part in this calculation. Anyway, I digress. So Riley's ready. All we need to do now is plot the line and see the curve. But that's the thing, we aren't getting the curve, yet the bridge experiment implied that we would. And I'm looking at him on the spinny ball, so my perspective should be able to capture his position and see the curve. How do these two experiments have vastly different results? Maybe Wolfie has proved that we're living on a rolling pin. But that's just ridiculous, surely, because the assertion is that we can only see curve on the z-axis. So is this experiment proving the ball, or is this experiment proving the rolling pin? Or could it just be that no matter where we go in the world, all we ever see is flat?